So the first case, there's 4 different things that could happen with law of sines, ambiguous case. The first one we're going to talk about is the no solution case. So in the case that you have this side is some undetermined length, this side is going up this way, and let's just say that this side has a length of 5, and that this side is coming down this way, and it has a length of, say, 3, and this angle over here is 40 degrees, and you want to determine, and in the book they'll say, will this make 1 triangle, 2 triangles, no triangles, or so on. And the way, what you have to do for each one is to drop down an altitude of the triangle. So you're going to take your, you draw a little picture, and this thing would be the altitude or the height of the triangle, and that's a 90 degree angle. So it so happens that if this 3 is shorter than the altitude from here to here, you understand that it's not going to reach. Okay? And we're going to call this side, for practical purposes A, and we'll call this side for practical purposes B. And so this would be angle A over here. So if I could make a triangle, it looks something like this, but in this case, it's not going to reach. And the way I know that is by finding out what this height is. Okay? And the way you find that height is by using right triangle trick. So the sine of 40 is equal to h over 5. Right? So h in this case comes out to be 5 sine 40, which if you do that on your calculator comes out to be about 3.2, okay? Which comes out to be about 3.2. So because this piece, this height is bigger than this, it's never going to reach. So ambiguous case, no triangle when A is less than H. So that's case 1. Case 1. In your book, they might order the cases into the book. So that's the easiest one, right? Piece of cake. Okay? So I'm going to move on to case 2. Did I go too fast? You want to see that again? You want me to go back? I could go back. I could go back. I'm going to pause. All right. So the next case, boys and girls, is now that we've had a little levity. Case 2. Case 2 is A equals B, where you have 1 right triangle. 1 right triangle. So for example, if I had a triangle that it's kind of hard to do this one because you have to kind of make up the numbers so they work. But so here's a side, here's another side going up this way, and I had to make this angle exactly 53.13 degrees. 53.13 degrees. And then again, I'm going to tell you that this is 5 again. And then that this side over here, A in this case, is going to be 4. Okay? So this is 4. And then I kind of do the same thing. I try to find the height of this triangle. Okay? Look at how I use that dotted line. Okay? H. And I call that H. So it turns out that in this case, sine of 53.13 equals H over 5. It turns out that in this case, I get that H is almost exactly equal to 5 sine 53.13, which comes out to be equal to 4. Okay, which means that this side would exactly touch here, and you can only have one triangle. Okay? So that's the case in which A, which is again this side, oh, that shouldn't say A equals B. That should say A equals H. Right? So if this opposite side is equal to the height of the triangle, does it come out to be 4?
It's 3.999.
Yeah, 3.999. So essentially it's one. I mean, it's impossible to get it exactly perfect unless it's a special right triangle or something like that. But yeah, then it comes out to be 4. Okay? So that's case 2. That was easy, right? Now it gets harder. Because now we, well, let me turn up. Now we have case 3. And I'll show you this one now. Okay? Arrow in the end, no dotted lines anymore. Let's do a different color because I'm tired of this color. Okay. Oh, that's not a very exciting color. So, okay. So now, and one more side, we need 7. We'll call this side 7. This side 5. This angle, in this case, is going to be 37 degrees. All right? And now I'm going to drop down my height again. Down here. Okay. And in this case, I'm going to find H. So now I do sine of 37 is equal to H over 7. Should be degrees, right? So 7 sine 37 equals H. And what do you get if you do that?
4.2.
About 4.2. Right? So H is 4.2, which means that this can either swing out this way or it could swing in this way. Okay, so the case 3 is you have two triangles, and that's when A, which is this side, and B, which is this side. A is less than B, but it's bigger than the height of that triangle. Okay, so A is less than, it's bigger than H, but less than B. So yeah, in all these cases, you have to go and find them. Now, to solve this, you have to use, so let's look at the first triangle. So say this triangle went out. So say we want to look at this triangle. Right? There's the one triangle that it could be. So I'm going to call this, whoops. That should be A, shouldn't it? Over there. I messed up again. This should be B, right? And this I'm going to call angle B over here. And this I'll call angle C over here. So now to find this angle right here, B, because they'll say solve the triangle. They'll say solve both triangles, show which triangles it could be. So I'm going to get sine, I'm going to say sine of 37 is to 5 as sine of B is to 7, right? And we haven't really done one like this yet, where you have to find the angle instead of finding a side length. So the first thing you do is you cross multiply, and you get that sine of B is equal to 7 sine of 37 degrees divided by 5, right? So I'm going to plug that into my calculator. Watch me go. Yeah, we're going to do that after, okay? So you could plug it all in one chunk, or you can just, it'll come back. Let's do always in front, then it should stay there, okay? So if I go 7 sine of 37, 7, making sure you're in degree mode, sine 37 divided by 5, I get a decimal number. If you don't get a decimal number, but between -1 and 1, you know that you did something wrong. Okay? And so I get 0.8425 something, okay? So that means that sine of B is equal to that. So to get angle B, I have to take the inverse sine of that, right? Inverse sine of 0.8425, okay? And on your calculator, you could go just second sine, second answer, and you should get that angle there is 57.49 degrees. 57.4 degrees. But you're not done yet. Yeah, so you have to solve the triangle, you have to find all the pieces, right? So you also have to find this angle here, and you have to find this side here. So to do that, C is easy, right? You just add these up and subtract from 180, and you get that angle C is 85.59. All right? Do I have to do that? Angle C is about 85.6 degrees. Okay? And then to find side little c, which is this side from here to here, I can now go sine of 85.6 is to c as sine of 37. Sine of 37 is to 5. And then I cross multiply and divide, and I get c is 5 sine 85.6 divided by c equals 5 divided by sine of 37. And if I do that on my calculator, I get that is approximately equal to 8.3. Whatever the units happen to be. Let's say it's feet. Okay, so C is 8.3. So that's one triangle. You have to go through all that for one triangle. Now you got to do it for the other triangle. So the other possibility, right, is that this thing, instead of swinging this way, swings over this way, right? But the sine of this angle needs, in order to make law of sines true, the sine of this angle has to be the same as the sine of this angle. So what angle would have the same sine as the sine of 57.4? Very good, because remember from trig, right, that, I mean this is trig, but from our unit circle, sine is positive here and here. So the sine of this angle here is going to be the same as the sine of this angle here, right? So to get that angle, I would have to take 180 and subtract that angle. So the other possibility, my other possibility is that, let's see if I could squeeze it in over here, is that angle B is 180 minus that, which comes out to be 122.6, right? 122.6 degrees. And then, so in that case, this would be 122.6. And then I add up to 180 and I find this teeny little acute angle there. So in that case, angle C would be 20.4 degrees. 20.4 degrees. And then I have to find side C as well, right? And so to find side C, now I use 20.4, so I get that sine of 37 is to, this piece is still 5, right? Doesn't change. Is to 5 as sine of, I'm going to put a hole in the graph here, as the sine of 20.4 is to C, right? C. And if you do that, what do you get, Logan? Or someone? 2.9. Someone 2.9. So C comes out to be 2.9, which makes sense because this side needs to be shorter than if it was a triangle where this angle is bigger, right? So that's what it means by find both triangles. So first you find one, this being an acute angle, then you find this being an obtuse angle, but always you have to find this top angle first, you know? And so then you've solved two triangles, okay? Questions? Yes, sir.
How did you get 122.6?
How did I get 122.6? I subtracted 57.4 from 180. See? Because this angle could either swing this way, right? Or it could swing this way, but the sine of 57.4 is exactly the same as the sine of 1. If I plug into my calculator, sine of 122.6,
So
I will also get 0.8425.
That's complementary.
Supplementary.
Supplementary.
Supplementary, yeah. Because when we learn, like, sine is positive in two places, right? It's 0.8425 over here, and then it's 0.8425 over here. See, if I did sine of, watch, if I did sine of 122.6, I should get out 0.842, same thing, see? Approximately, because I rounded off one. Okay, last case, last one. Okay, case 4, and that's the case in which you have one obtuse triangle, and that's triangle, and that's the case in which A is bigger than B, and that one's not very tough either. You just, I don't want to do that. I want to make it, put an arrow on the end. I want to make it solid. Okay? So yeah, he's still recording. So I'm going to go this way. I'm going to call this side, in this time, I'm going to call this side 5. And then I'm going to call this one over here, whoops. And then this one over here is going to be like 7. Okay? So you know that this side, if all you need to know, you don't have to find the height in this case. Because all you need, the height doesn't matter, because if this side is bigger than this side, oh, and this angle is 27 degrees in this case. So this angle is fixed, this side is 5, and this side is 7. So the only way it could swing, it can't swing over here because it will be outside the triangle. So then you could solve the triangle the same way you did before. Sine of 27 is to 7, sorry, is to 7. As sine, we'll call this B. As sine of B is to 5. So then you cross multiply and you get that, what do you get? You can do that, right? I'll do it anyway, okay? So you get sine of B is equal to 5 sine 27 over 5 over 7, right? And so let's just do that real quick. 5 sine 27 divided by 7, and you're going to get some decimal answer, and then you take the second sign of that to find B. Second sign, second answer, and I get that B, so that this little angle here is 18, so angle B is about 18.92 degrees. So once you know that, then you could find that by subtracting from 180, and then you could find sine C by just doing law of sines again. Okay? Easy. So there's 4 different things. Now in your book, you got to be a little bit careful, because sometimes they'll call side, I would always set it up like this. Like they'll give you one side B is 5, angle B is 37, I don't know, and side C is 2 or something like that. I would always draw the picture like I've been drawing it. There are other ways to draw it, but just to kind of be consistent, you know, I would, so I would draw it like this. I go, okay, here is I just keep drawing it like I'm drawing it, okay? And except you're going to call A and B different things. So I would say here's your 37 degrees. Here is angle this, and this is angle B. So side B would have to be the one opposite angle B. So I would call this side over here your 5, and then I would call this over here 2, right? How many triangles will I have? 1, right? So just to be consistent, you know, just kind of draw your picture like this. You could draw it where, like, this is one of the given sides. So say they might give you this side, and then they might give you this side is 5, and then they'll say, okay, this angle over here, that would be angle side, right? Maybe this angle is 40 over here. But could you do it that way?
Yes, you can.
Yeah, and then let's see, the 5 couldn't come over that way, right? But this angle could change, right? This angle could change. But just to kind of keep it straight in your head, I would always draw the picture like this. That's what I've always taught kids to do. Okay? So anyway, homework. Page 538. Pretty straightforward, not too many problems. I'm not making you do those first easy ones. 6 or the ones that some people never do anyway. 31, 6, 8, 31, 36, 36, 43, 50 and 52, and that's it. And remember, you heard it here on Mr. Leader's
Video's hot.
Thank you.
Yeah.